In this video, we're going to revisit a simple molecule we looked at before, carbon dioxide. We drew this Lewis structure earlier, but there are some alternative ways we could draw the Lewis structure for this molecule. So the Lewis structure we came up with was a double bonded oxygen on either side of the carbon with the two lone pairs on each of the oxygen atoms. So this is the structure of carbon dioxide, and this is the best structure for it. But we're going to look at why it's this structure and not this one, where we have a triple bond on one side, or the other version where we have a triple bond on the other side. All right, these are all valid resonance structures, but I asserted and said this is the actual best structure for carbon dioxide. But now let's go ahead and use formal charges to figure out why it's this one and not the other ones. So let's just calculate the formal charges of all the atoms involved here. All right, so we'll just go from left to right. So starting, maybe I'll use 3 different colors. So starting with this oxygen here, its formal charge is going to be equal to 6 minus 4 non-bonding electrons plus 4 over 2 bonding electrons, which gives us 6 minus 6, which is equal to 0. Oh, that's already great. We want to have formal charges of 0 whenever possible. And actually, the other oxygen is the exact same, so its formal charge is going to be exactly the same. So this is 0, and this one is also 0. Now we'll look at the carbon in the middle. Its formal charge is equal to 4, so the 4 valence electrons in free carbon. And then we subtract off 0 non-bonding electrons plus 8 over 2. So 8 bonding electrons with the 2 double bonds. So we end up with 4 minus 4, which is equal to 0. So all the charges add up to 0, and this is our structure where we minimize the formal charges. So the best structure is always one where you can set all the formal charges equal to 0. So by far, this is the best structure and most representative of the actual bonding in carbon dioxide. But let's go ahead and look at these ones here. All right, so we'll just do the top of these two. The formal charges will be the same when we switch to the bottom, just the 2 oxygens will be different. All right, so this first oxygen, the formal charge is equal to, again, 6 minus 6 non-bonding electrons plus 2 bonding electrons, which gives us 6 minus 7, which is equal to negative 1. Okay, so it's already not 0. We can do the carbon in the middle, and we end up with actually the same exact calculation we had before. It's 4 minus 0 plus 8 over 2. We still have a total of 4 bonds to carbon, and those electrons are shared equally, so we end up with 4 minus 4 again, which is equal to 0. And now let me get a new color. We'll do yellow for this oxygen here. Its formal charge is equal to 6 minus, now we only have 2 non-bonding electrons and 6 bonding electrons in that triple bond. And we'll finish this in just a second.